Hello everyone, welcome back to my channel. So in this video we are going to see what is bonus tolerance in GD&T in geometrical dimensioning and tolerancing. Okay, so before coming to this session, before coming to this video, it is considered that you know the basic GD&T, you have understanding of the GD&T. So I will show you one simple example here. Okay, you can see this example on my screen. This is a simple plate, rectangular, we can say square plate. Okay, having the hole in between of dia 10 mm plus minus zero point 0.2 is the tolerance. So how this is, we can say, defined in the GD&T, you can see this. So this can be defined like this. These are the basic dimensions, and then this is the feature frame. So now in this video, I'm not going to explain all the feature frame. What do you mean by the feature frame and what are the basics of the GD&T? But here we are going to see what do you mean by this positional tolerance and what is the symbol called. Okay, and what is the bonus tolerance. So that is the important thing that we are going to cover in this video. So let me explain the meaning of this symbol. Okay, so here we have applied the tolerance of, we can say, positional tolerance of 1.4 dia. That means the position of this hole is allowed to shift into the, we can say, diametrical tolerance of 1.4. Okay, so I will show you in next slide exactly how it is. So suppose this is our hole and this is our mating part. One pin is going into this hole, that is the dia of, we can say, 8.4. okay, now here a diametrical tolerance of 1.4, that means the center of this hole of the plate can be shifted in the diametrically 1.4 mm. Okay, that means you can see, I'll just shift it here. If that hole is here, you can see the center is within this tolerance, right? Then it will be accepted. Okay, if it is here, again it will be accepted. If it is here, it will be accepted. So anywhere in between this diametrical, we can say, circle of this 1.4, if the center appears between in the circle, still it is accepted. That is the meaning of this diametrical positional tolerance. I hope you are clear with it, and that is a basic of, we can say, GD&T. And then it is symbol is applied here, that is symbol of maximum material condition. So in few minutes we are going to see that what do you mean by maximum material condition and how we get bonus tolerance with the help of maximum material condition. So as of now, let's consider we don't have the symbol here. Okay, here is just positional tolerance of diametrically 1.4 with respect to the datums. So just consider as of now we don't have the symbol. So what is the exact meaning of this? I'll just write down here. That means, okay, if the hole is produced at the, we can say, 9.8, that is the minimum dia, right? 10 plus minus 2, that is 9.8. So still you will get a diametrical tolerance of 1.4. okay, then if hole is produced at, suppose, 10, exact 10 dia, then still you will get a diametrical tolerance of 1.4. Then if hole is produced at the 10.2, that is, we can say, considering the maximum tolerance, still you will get a diametrical tolerance of 1.4. That is a normal GD&T. But what will happen if we add this symbol here? That is a maximum material condition. Let's understand the term maximum material condition first. What do you mean by maximum material condition? Okay, so maximum material condition means the hole, if the whole dia is less, that means there is a maximum material condition, right? So this is a plate and we can say, adding the hole into the plate. Okay, considering this tolerances, if hole is produced at the 9.8, that means we have less diameter, and less diameter means we have more material available, correct? So here in this case, 9.8 is your maximum material condition. Okay, So by adding this symbol, we are telling manufacturer that this diametrical tolerance is just for the maximum metal condition. That means just for a 9.8. If we go means if you produce the hole at the 10, then you will get a more tolerance. Then if you produce the hole at the 10.2, then you have, we can say, benefit to get more tolerance. So I will explain that into the next slide. Okay, so this is same, we can say, plate. Okay, this is just enlarged. The blue is our plate, white is the hole. Okay, you can see this is the nominal diameter 10 mm and 8.4 is your mating part. Okay, now what's happening, the concept, just understand the concept, guys. Okay, why bonus tolerance is required and why to give maximum metal condition. Just understand the concept, that is important. Okay, so this is your mating part 8.4 and just your dia is 10 mm. Okay, now considering suppose your hole is produced at the 9.8, considering the plus minus 0.2 tolerance. So if your hole is got produced at the 9.8, that means you have clearance of 1.4, correct? Diametrical 1.4, 1.4, right? So 9.8 minus 8.4, that is a 1.4. So which is highlighted here, diametrical tolerance of 1.4. That means the mating part is of 8.4 dia and your hole is got produced at the 9.8. That means you have the tolerance of 1.4. So 9.8 is your maximum metal condition. So let me write down here. So when hole is got produced at the 9.8, you will get a diametrical tolerance of 1.4. But we have denoted it by the maximum metal condition. That means this tolerance is just for the maximum metal condition, right? For example, now if your hole is got produced at the 10, which is not maximum metal condition, correct? So it is exactly produced at the 10.0, I will write it. Okay, so what is the extra benefit that now you can see this hole is produced at the 10 and now you can see this gap, right? So we are getting this extra clearance here. We are getting this extra clearance and we can utilize this clearance to add this into the tolerance, right? So this 0.2, we are going to get it extra here. So it will be 1.6, right? Now hole is produced at the 10.2. Let's consider it hole is produced at the 10.2. This is 10.2. Now you are getting like 9.8 to 10.2. 1.4 you are getting extra. So you will get it 1.8. So just compare this case. You can see 9.8, 10, 10.2. So irrespective of the hole diameter, your diametrical tolerance is same here. If you are not applying maximum metal condition symbol here. But if you apply maximum metal condition symbol, that means you are allowing manufacturer to get extra tolerance there, because we are getting extra, right? If this hole is produced here, then we will get this tolerance. If this hole is produced here, then we will get this tolerance. If hole is produced here at the 10.2, then we will get this extra tolerance. So you can see 1.4 is denoted, but we are getting 1.6 and 1.8 also, which is not here, in the, we can say, numbers, but this symbol denotes that you can go up to 1.8, and that is called bonus tolerance. And we get this type of the tolerances just by using the symbols maximum metal condition and sometimes the least metal condition. So I hope you understood this concept, and if you like this video, just like this video, share with this video with your friends, and if you wanted to watch such a type of the video, just subscribe to my channel. Thank you. Bye bye.